All right, welcome back. So what we're going to do here, this is number one. So we're taking, what are we doing? We're finding dx dt. We got to take the derivative of this with respect to t, act like it's okay. So it's 2, but then that was an x. So I got to attach a dx dt plus 3, act like it's okay. So the derivative of 3y is 3, but I got to attach a dy dt. And then that equals derivative of constant 0, right? But then dy dt is 2. So we're going to plug that in right here, right? So 6. So long story short, 2 dx dt plus 6 equals 0. So that equals minus 6. So dx dt equals minus 6 divided by 2, which is minus 3. Pretty easy deal, right? So the next odd or 2 should be pretty easy as well. So let's move on to number 13. Number 13, it says it's sand, but we're going to make it corn since we live in Iowa, right? So we got corn coming out of the auger and dropping into a conical pile here. So it's an upside down cone, right? And so this is number 13, being dropped at a rate of 10 cubic meters per minute. Okay, so what is the variable? So it says 10 cubic meters per minute. So if you're not sure how to label this, or how, like what variables go with that, that's a rate of change, isn't it? It's dropping down on her. So what would, by the way, I didn't put a minus sign. Some people might wonder if there's a minus sign, but what's cubic meters? What's that represent? Volume. So this is a change in volume with respect to time, right? So this is dV dt. Now I got a question for you. As far as the plus or minus on the 10, do you want a plus or like which one do you prefer? You want it to be positive or negative? Positive. Why? And that actually makes sense in this problem. Because what's the volume doing as you pour corn on top? It's increasing, right? So positive is like an increasing volume. So it's okay that this is positive, 10 cubic meters per minute. So that was given. And then it's a conical pile. The height of the pile is always twice the base of the radius. So here's the height of the pile is always going to be twice the radius. So that the height is 2 times the radius. Now, if you're not sure, like which way to do that, give yourself an example. Well, if the height is 10, what would the radius be? 5, right? Because the height's always twice, and how do you get it? Well, I'd have to take 2 times 5. Now, if you wanted to, and what we're actually going to want to do is we're going to want to solve this in terms of R because of what the rest of the problem says. But it says if the height of the pile is always twice the base of the radius, at what rate is the height increasing when the pile is 8 meters high? So it's saying at what rate is the height increasing? So as corn pours on this, the height's getting bigger, right? But at what rate is the height increasing when the radius is, no, when the pile is 8 meters high? Now we could figure out, possibly what the radius is if we can figure out what the height is. But the pile's 8 meters high. So what would the radius be here? At the point in time where you have 8 foot high, it's the same math. What would the radius be? It'd be 4 meters, right? So like we could figure that out. So I could also have said at what rate is the height increasing when the radius is 4 meters. But the reality is they put everything in terms of the height. So we want at what rate is the height increasing? What letter is that? H. And then H equals, at the point in time where H equals 8 meters, right? So here's, what equation do you know? So we've got dV dt, right? What's the volume of a cone? Well, if it was a cylinder and you could turn it upside down, it looks the same, like a pop can, it'd be area of the base times the height, right? the base is a circle. What's the area of a circle? What's the area of a circle? Formula, pi r squared. And then times the height. So this is if it's a cylinder, but it's a cone. How many cones fit in a cylinder? 3. So it's 1/3. So it's 1/3 area of the base times the height is volume of a cone. So this is volume of a cone. By the way, I put a leg on my V, otherwise it looked like a U. That's why I put that V out there. Anyway, but this is volume here, right? How many variables do I have? I got 3, right? Volume's a variable, radius is a variable, and height's a variable. How many do I want? How many do I care about? How many did the problem talk about? It talked about 3. But like over here, I have height, and then I have dV dt that's given. So what do you want to try and do that would make life a lot better for you? Get rid of what letter? Which one do you want to get rid of? R. Get rid of R. So how would I get rid of R? So if H equals 2R, what's R equal? H divided by 2, right? Meters. By the way, this is in meters. Radius is in meters. But so what's this equivalent to? This is 1/3 pi times H over 2 quantity squared times H. And then, of course, I'm going to simplify that a little bit. So I'm just going to, H over 2 quantity squared is H squared over 4, right? But I can take the 4 times 3 on the bottom, and it's 1/3, or basically pi is a number 2, right? So it's pi over 12, because that's 3 times 4 is on the bottom, right? And then H cubed. So this is the volume right there. So the volume equals pi over 12 H cubed, right? Now, what have I been given? I've been given dV dt. What am I looking for? At what rate is the height increasing? Well, at what rate is the height increasing? That'd be a change in the height with respect to what? Time, right? And how do you do that? So what am I looking for? How do I write that? dH dt. I'm looking for the rate of change of the height with respect to time. So it's a rate of change, right? So it's a derivative. So it's dH dt. Now, how am I going to get that from this equation right here? What do you think I need to do to both sides of this equation? Take the derivative with respect to time. So do you see, kind of how we finished off the last section in 2.9 and 2.10 have a lot in common, right? So it's related rate. So it's derivative with respect to t. So let me come back. I don't have a lot of room up here. Let me come up here. So, and we're looking for dH dt when h equals 8. At what rate is the height increasing when the height is 8 at the moment in time? Because this pile is getting bigger with the corn coming down, right? So we're flowing lots of corn in thankfully a good couple of harvest years in a row here. But anyway, so what do I get on the left? What's the derivative of v with respect to t? Yeah, like it's okay. It's 1 and then dV dt, or you could just say the derivative of v with respect to t is dV dt. That's the easier way to do that one. But anyway, so it's a different variable, right? But dV dt is what you get on the left side. On the right side, it's a constant times a function. That's why I wrote the pi over 12 kind of together like that. So it's pi over 12. Derivative of constant times the function is a constant times the derivative of the function. Derivative of h cubed is what? 3h squared, but it's an h, not a t. So what do I got to attach? dH dt, right? So times dH dt, that's what I'm actually solving for. And of course, the 3 cancels with the 12, and that's a 4, right? Anyway, so now I have dV dt. I'm just going to rewrite it. dV dt equals pi over 4 h squared times dH dt. And what am I solving for? It wants to know the rate of change of the height. How is the height increasing? Because as I pour corn, it's going up, so it should be increasing. So I better get a positive final answer, hopefully, right? Anyway, so plug in what we know. What do we know? We know that dB dt is 10, right? I can plug that in right there. So that's 10 cubic meters per minute. I don't need to worry about the labels. I can label it at the end. Equals pi over 4. And then what's h? It said h equals when h equals 8. So that's 8 squared and then times dH dt. Everybody agree? Okay, 8 squared is 64. 64 divided by 4, I don't know, divided by 2 twice. 32, 16. So 10 equals 16 pi dH dt. So finishing this up, solving both sides, or solving it for dH dt, I can divide both sides by 16 pi. So I get 10 over 16 pi, which is equivalent to what? 5 over 8 pi. And that equals dH dt. So 5 over 8 pi. But what we want to do is we want to then interpret this. So first of all, that was a positive answer, which is what we wanted, right? But what we can say is, how do we say this in words? What's changing with respect to time? The height. So the height of the pile is increasing because it's positive. So the height of the pile is increasing at a rate of 5 over 8 pi. And then what's the label? H is in what? Meters per minute. Okay, I believe that's, yeah, it was cubic meters per minute was the volume, so dH dt. So basically what we can say, finishing up here, the pile, the height of the pile is increasing at a rate of 5 over 8 pi meters per minute. So just make sure you say increasing because of that plus sign. All right, there you go. Do some odds and then the two evens. See ya.